Let's solve the problem about thermal expansion of steel rails. Two steel rails, each 10 meters long, are laid with a clearance of 3 millimeters between them at a temperature of 15 degrees Celsius. We need to find the temperature at which the rails will just touch each other. Let's visualize this problem. Here we have two steel rails laid parallel to each other. Initially, there's a 3 millimeter gap between them. The current temperature is 15 degrees Celsius. To solve this problem, we'll use the linear thermal expansion formula. The change in length, delta L, equals the coefficient of linear expansion alpha times the original length L naught times the change in temperature delta T. We know that the coefficient of linear expansion alpha is 11.7 times 10 to the negative 6 per degree Celsius. The original length is 10 meters, and we want the change in length to equal our 3 millimeter clearance. As the temperature increases, both rails will expand toward each other. When the expansion of each rail equals 1.5 millimeters, the rails will just touch. Let's solve for the change in temperature. We'll substitute our known values into the formula. Solving for delta T, we get delta T equals 0.00, 3 meters divided by the product of 11.7 times 10 to the negative 6 and 10 meters. This gives us a temperature change of 25.64 degrees Celsius. To find the final temperature, we add this temperature change to our initial temperature of 15 degrees Celsius. Therefore, the rails will just touch when the temperature reaches 40.64 degrees Celsius. Let's visualize our final answer. At 40.64 degrees Celsius, both rails will have expanded just enough to close the initial 3 millimeter gap between them.